Now something weird is going to happen when we solve or attempt to follow all the steps for 84 and 78. Our end result's not going to be a nice equation that like x equal 2, y equal 5. It's going to look funny. It's going to look like we did something wrong. So a good thing to do at that point is to check and make sure you did all the work right. But there's an interpretation of the weird results. And I'll show you by example what happens here. Let's look at this process. What is the process, the recipe we've been talking about, say to do first with problem 84? Get rid of the fraction. How do we get rid of this fraction? Multiply by 2. We can't just multiply the fraction by 2, of course. We have to multiply the entire side on both sides. So let's look at the left-hand side. The left-hand side is 2 times x plus 2 times 7. The right-hand side is 2 times this fraction plus 2 times 4. But 2 times this fraction, you're going to have 2 over 1 times this 2x plus 6 over 2. The 2's are going to cancel. And that's going to leave you with 2x plus 6. The 2 times 4 is going to leave you with 8. What's the next step in the process? What does the recipe say to do next? Gather like terms. So there's some like terms, namely 6 and 8, sitting on this side. They're separate. It's a good idea to get them together. Just combine them by adding. So this side becomes 2x plus 14 equals 2x plus 14. Okay. If that doesn't look weird enough to you, it's not. Yeah. Well. Yeah. Let's look at the proper interpretation of what that is. I don't like undefined. Undefined is not one of the options. Let's look in terms of this thing. So this thing is equal to this thing. What if x is equal to 1? Is that a true statement if x is equal to 1? Yeah. Is that a true statement if x is equal to 2? Let's see. 2 times 2 is 4, plus 14 is 18. 2 times 2 is 4, plus 14 is 18, so it's true for x equal 2. What about x equals 0? Is it true for x equals 0? Yeah. Sure, because you got 2 times 0 plus 14 is 14 here, and 14 here. In fact, is there any value of x that makes that false? No. Any number you choose to put in, any real number you choose to put in, is going to make that true. Now typically, by the way, so the solution here, I'm going to leave a little space, is all real numbers. What makes this equation true? All real numbers can make that equation true. Now what it will often look like, if you don't catch it here, you say, well, let's subtract 14 from both sides. Maybe. So I've got 2x equals 2x. Divide both sides by 2. X equals x. Maybe you see that. Or maybe you try to subtract x from both sides, and I've got 0 equals 0. But the thing all these endings have in common is you have an equation that is always true. You're saying this equation up here, when we kind of pull our steps for equivalent equations, multiplying both sides by the same thing, subtracting the same thing from both sides, adding same thing to both sides, dividing both sides by the same thing. When we do those steps, we get to a point where all of a sudden it becomes obvious. This is a statement that's always true. The word for that is it's an identity. And that may be how the book refers to, when you're looking up answers, is they may use the word an identity to describe an equation that's always true. The idea I want you to ask, though, is get used to asking, okay, a solution. When I'm asked to solve, I'm asked what makes the equation true. What makes the equation true? all real numbers make this equation true. So when you see an identity, when you see something that's always true, it's all real numbers that make it true. Here's another weird one. We've got 5 times the quantity x plus 2 equals 5x plus 2. No fractions to clear. We've got a set of parentheses to clear. So this becomes 5x plus 10 equals 5x minus 2. Now at this point you're seeing things weird. If you don't see things weird now, let's subtract 5x from both sides. And now we've got something that's really weird. 10 equals negative 2. A demonstrably false equation. The word your textbook is going to be using, that type of equation, is a contradiction. It's something that's just not going to work, ever. So is there any value of x that you can multiply by 5x, and have it be equal when you add 10 to it versus when you add negative 2 to it? No. This is a statement that's never going to be true. It is equivalent to this top statement. This top statement is never going to be true no matter what x you put into it. This is a sign that what there is no solution. So there's weirdness in both of these. How do you tell how to interpret the weirdness? If it comes down to something that is always true, something like 0 equals 0, 5 equals 5, 2x equals 2x, 2x plus 14 equals 2x plus 14. If it comes down to something that's always true, that's a sign that the solution set is all real numbers. All real numbers will make this true. Any real number you substitute in for x will produce a true statement. If where you end is someplace like 10 equals negative 2, statement that's just plain false, that's never going to be true, that's a sign that no value that you could put in for x is going to make a true statement up here. And if there's no value that you could do to make this true, that means there's no solution.